Kishore Nath, sir. Immediately. Okay, sir.
Good morning.
Good morning, sir.
Reddy garu.
Good morning, sir.
At the outset, I thank JNTU College of Pulvendala, Principal GSS Raju garu, and Sri Venugopal Reddy garu, and Rameshwar Reddy and Damodar Reddy for giving me opportunity to share my some of the work which we have done in our laboratory towards renewable energy sources. My presentation will be around 1 to 1.5 hours. At the end of the session, we'll have some interaction with the participants. I will share my presentation.
1 minute, sir.
Yeah.
My student will introduce about the resource person, Dr. Kishore Nath, sir. My student name is Dr. K. Rahul, MTech student. Please give a brief review of the student.
Good morning to the respected resource person. Sir, I would like to give a brief introduction about the resource person on the lecture of renewable resource for industrial and domestic application. Dr.N.Kishore Nath, sir, presently working as scientist G in project director Veda in Advanced System Laboratory and DRDO, and Dr. APJ Abdul Kalam Missile Complex and Missionary of Defense, Government of India, Kanchanbag, Hyderabad. Sir has 24 years of experience in design and development of advanced composite structures for missiles and aircraft. Project handled by the N. Kishore Nath, sir. Sir designed and developed composite flame deflector and radom and PF warhead for Prithvi project. Sir developed composite fuel drop tank, 1200 liters and 800 liters for light combat aircraft Tejas. Sir developed composite rocket motors, flex nozzles for large solid rocket motor project Agni 4. Sir developed composite grid signified plates and jet deflector ablative liner for programming Agni. Sir published 74 papers in international and national journals and presented 25 papers in international and national conferences. Sir has been awarded DRDO Laboratory Scientist for the year 2003 and DRDO Performance Excellence Award 2004 for successful realization of Agni 4 system, enabling a quantum jump in technology of long-range missiles and new capabilities of defense. And Agni Award for Excellence in Self-Realization 2015 by Chairman of DRDO and Secretary, Department of Defense and R&D, New Delhi. And Sir has fellow memberships in professional societies like Fellow in Institution of Engineers in India, Fellowship in Scientist of Manufacturing of Engineers, Fellow in Indian Society of Mechanical Engineer, ISME, and life memberships in Aeronautical Society of India, AESI, and Sensor Research Society of India, SRSI, and Astronautical Society of India, ASI, and Hyderabad Management Association, MHS. Thank you, sir, for the lectures.
Thank you.
Yes, sir. Okay, sir. Very good. Please continue, sir.
Yeah. Is my presentation visible?
No, sir.
Okay. Screen vastunda?
Vastund, sir. Vastund, sir. Okay. Yeah, now it is visible, sir.
Okay, Ramesh Reddy garu. Sorry for the disturbance. That new system, I am not conversant with this.
Okay, sir.
That's why it got delayed.
Fine, sir. Continue, sir. Please, sir.
Renewable energy sources for industrial applications, my topic of today's presentation. I am Dr. N.Kishore Nath, Scientist G, Project Director with the Advanced System Laboratory, DRDO, Hyderabad. We have done some research work on renewable energy for the windmills blades in composites. We have developed around 20 years back with one project called windmill turbine blade development. It is sponsored by Ministry of Non-Conventional Energy Sources. With that, I have some association with the renewable energy. I will start my presentation. The energy resources which can be used to produce again and again are known as renewable energy sources. Different forms of renewable energies, as you know, solar energy, wind energy, hydro energy, tidal energy, biomass energy, and geothermal energies. Solar energy, as you know, it is widely used nowadays because of its plenty available. There is no limit for solar energy. How much you can tap, it depends on your usage only. So this is even used for aircrafts also. We are trying to use solar energy. So already people are flying with solar panels on the aircraft, and they are going from one place to other place without any issues. 1 minute, I am not able to go to other slide. Thank you. Solar energy is the transformation of heat from the sun that is harnessed using a range of ever-evolving technologies. In simple words, solar energy is transformation of heat energy that comes from the sun into electrical energy. Photovoltaic cell directly converts solar energy into electrical energy. In this solar energy, photovoltaic cell is the main element which is converting from heat energy to electrical energy. Edmund Becquerel, he is the father of solar panels. He invented photovoltaic effect in 1839. Solar energy, thermal panels are used to generate heat energy. Photovoltaic cells are made from silicon. It turns electrical sunlight directly in heat into electricity. So this is the pictorial diagram where we can see solar panel with silicon positive and negative. So once the solar energy falls into photovoltaic cell, it converts into electrical energy. So solar panel construction, solar panel technology is advancing rapidly with greater efficiency and lower prices, resulting in a huge increase in demand. Initially, photovoltaic cells were very costly. Nowadays, because of government initiatives and more production of photovoltaic elements, the cost is coming down. However, despite massive advancement in technology, basic solar panel construction hasn't changed much over the years. Most solar panels are still made up of series of silicon crystalline cells sandwiched between glass plate and polymer plastic backsheet supported with aluminum frame. Once installed, solar panels are subjected to severe conditions over the course of their life. Solar photovoltaic cells are made using silicon crystalline wafers, which are similar to the wafers used to make computer processors. The silicon wafers can be either polycrystalline or monocrystalline. The most efficient type of monocrystalline, which are manufactured using well-known Chokorsky process. Solar panel constructions, the process is more energy intensive compared to polycrystalline and therefore more expensive to produce. Monocrystalline silicon cells, then highest efficiency and highest cost. Cast monosilicization cells, high efficiency and lower cost. Polycrystalline silicon cell, low efficiency and lower cost. Manufacturing of crystalline silicon cells, the silicon sand is purified in an arc furnace to create 99% pure silicon. The 99% silicon is further refined to close to 100% pure silicon. The silicon is doped with boron or phosphorus. The doped silicon is melted and extracted into crystalline ingot. The round ingot is diamond wire cut into square wafers. So manufacturing of crystalline silicon cells, this is the process. The thin based wafer is coated with an ultra thin layer of either P-type or N-type silicon junction to form the PN junction as shown in the figure. The anti-reflective layers or metallic flingers are added to the cell surface. Flat ribbon bus bars or thin wire bus bars added as shown in the figure. In our laboratory called Advanced Research Center near to our DRDO in Hyderabad, there are a lot of research going on in order to remove the water or droplets falling, dust falling on the solar panel glass, that removes without any effort, so that the efficiency of the solar cells will increase. So there are 6 components of main solar system. So you can see solar photovoltaic cell, then toughened glass. On this toughened glass, there is a lot of research going on in our Advanced Research Center International ARCI in Hyderabad. Extruded aluminum frame, then encapsulation or EVA film layers, then polymer rear backsheet, junction box, diodes and connectors. These are the sequence of the things shown here. Solar thermal energy have a potential to contribute to industry so much of joules in industry by 2050. Most common applications in solar thermal energy used in industries are solar water heaters, solar devices or drives, solar water pumps, solar cookers, etc. I want to tell, way back in 95 when we completed engineering, we have done a project on solar water heaters in J&T College of Engineering, Anantapur, under the guidance of Durga Prasad sir. So I am very happy to tell that we have done some project work way back in 25 years back itself. Then if you see solar panels, most of the industries, they are using solar panels to generate their own energy, like Apple, which is a giant in computer devices. They are using their own solar energy in order to meet their own energy requirements. So like this, other companies like Apple, then Google, they are all using solar energy very efficiently, so that they cannot depend on main supply from the states or government. They are generating their own energy, and excess energy they are giving it to grid. So like Apple, they are using in Singapore, they are using other buildings also to generate solar power for them. So this is one of the example. Then Walmart, this is also, they are using entire rooftop for generating solar energy. There are mostly 145 megawatts they are using to generate solar energy. So Intel is also widely using solar energy for their own development and usage of energy for their applications. So like this, in China is the major source industry who generates solar power for the entire industrial use. So this is one of the photograph. Then if you see, there are various advantages of solar energy, and some some of the I mean to say some disadvantages also there that are also listed here. You can see stable price levels compared to other energy sources. Cost per energy unit is zero after one-time investment. Solar energy is renewable energy source. Solar energy is a proven technology with a long history. Solar power is sustainable literally until the end of the time. Most effective power source for remote areas. Solar panels can be used all over the world. Solar power is available all year long and can be stored for rainy days. Like this, there are so many advantages. Some of the disadvantages are initial cost is very high, and the panels, it covers wide area. Wide area is required to put these solar panels. So these are the main 2 disadvantages. Otherwise, solar energy can be used efficiently. One more, in our laboratories also, we are extensively using solar energy. We have planted solar panels in our rooftop and car parking areas, and extensively used even in our defense usage also. Most of the places we are using solar energy. And the next renewable energy source is wind energy, where we have done some research work, which I wanted to share that research work which we have done for wind energy. Design of the blade, that composite blade we have designed long back. So that I will going to share. So wind energy is the process by which the wind is used to generate the electricity. We have plenty of wind in our areas, especially southern India. So where we have almost throughout the year, the wind will be blowing. So that energy we want to harness. So we have done some research work, and the windmill energy blade has been developed long back, and the technology is given to industries. Then wind turbine converts kinetic energy in the wind to mechanical power. A generator can convert mechanical power into electrical power. Then Charles F. Brush has invented the wind energy. China produced almost 17,784 megawatts, which makes it leading wind energy power generator in the world. This is so if you can see the main components of the wind energy mill, so it is a tower, and this is the propeller blade, and this is the nozzle containing generator. Then wind farm, strong winds, clear hilltop, turbines in prevailing wind energy direction. So wherever the wind is blowing continuously throughout there, we can establish the windmill energy. Wind energy is a free and renewable source. There will be same supply in future no matter how much is used. So it is a source of clean, non-polluting electricity. It does not emit pollutants or greenhouse. So there is no pollution from this wind energy. It's a clean fuel source, does not pollute air like power plants and that rely on the coal or natural gas. So one more advantage is there is no pollution and there is no consumption of any resources from the nature. This is the two advantages of the windmill energy. The only disadvantage is it generates a lot of sound to the nearby areas. So this is the formula for generating windmill power. So half rho AV cubed. So this, if you see the construction of the blade, so because the windmill blades are very lengthy and it occupies more diameter, naturally the blade weight has to be controlled. The blade weight has to be as minimum as possible, and it should be aerodynamical shaped. So that's why it is made in composite materials. So the cross section of the blade consists essentially the outer shell, and these are the two outer shells, and in between for the strengthening purpose we have internal structural support, and we have a trailing edge and leading edge. These internal members are also called as spars. So this is the main construction of the blade. So there is one more way of making the blade. So in order to avoid the weight, we can make a sandwich panels. So outer face sheet and inner face sheet, and in between foam we can use, so that we can reduce the weight and the stiffness can be increased for the blade manufacturing purpose. So two aero shells are bonded to load carrying with the spar beam called box beam. This inside construction like a box we can use to distribute the strength to the blades. The main spar and the wing shells are manufactured separately and then joined in a separate bonding process by using adhesives. So you can see this is adhesive bonding. So this is the top skin and this is the bottom skin, and we have a trailing edge and leading edge. So this main box section is manufactured by using monolithic composite, because this is the loading member which takes the entire load. So main loads are on the blades which comes, so we can see flap wise load and edge wise load. So this aerodynamic shape will be that like a aerofoil shape. We have to design the blade so that when the wind flows, the blade rotates. The main loads on the blade are generated by wind and by gravity. Then the wind loads are mainly induced both flapwise and edgewise bending. Gravity loads are mainly induced edgewise bending when blade is horizontal. The rotation of the blade causes alternating edgewise bending and thus the fatigue of the material. So this material will be, the blade will be continuously rotating. That's why the fatigue load is also very important to consider in the design. So the key structural design requirements, it resists the extreme loads and resists the fatigue loads, must be stiff to prevent collision with the tower and extreme loads, and as light as possible. That's why we are making this windmill blades with the composite material like e-glass fiber, polyester resins. Then it avoids resonance. That is also one of the important parameters we have to consider during the design. Then if you see the graph, so composites is having more strength and less density, so that it is a candidate material for manufacture of the blades. In terms of stiffness also, composites will meet the requirement. So if you see the construction of the material, so this is the bottom top skin and bottom skin made of composites with the different layers like 0 degree, 90 degree, plus minus 45 degree, depending upon the design. We have to choose the layer lamina sequence. Then the main between top skin and bottom skin, we use core. Like a core, we can use like a honeycomb core or a foam core also we can use. So monolithic laminates consist of different layers of multi-directional fabrics or unidirectional fabric, and a sandwich composite consists of low density core between thin faces of composite material. So if you use the sandwich composites, so when the load is applied, the outer fiber will take the tension and the inner fiber will take the compression load. So if you see the main thickness of the skin is T, then foam we have to do 2T. So the total thickness will become 4T. The insertion of core increases the thickness of the structure and thus the flexural stiffness and strength without increasing its weights. So this is the way the sandwich construction we have to make for the manufacturing of the blade. So process of manufacturing blade, there are various manufacturing techniques, but we have used wet hand lab technique for realization of a 20-meter long blade with 1.5-meter width in our laboratory long back. Then vacuum infusion technique, pre-peg technique, resin infusion, wet hand lab, filament winding, blade infusion. These are the main techniques. Nowadays, vacuum infusion technique mostly used by the industries. So pre-peg technology, the industrial impregnation of fiber, then forming the impregnated fiber to complex shape. So this technology gives production rate more. So we can make the pre-peg in an impregnation plant, and finally we can use the pre-peg for the realization of the blade. So this is the schematic diagram shown here. So this is the way, this is the mold surface, we have to use release film, then pre-peg, core, pre-peg, then we have to use the peel ply, then to get the better texture, then breather and vacuum bag. So it consists of fiber impregnated with resin that is not fully cured. It is called B stage. The pre-peg we have to use. Then the pre-pegs are laid upon to the mold surface, then vacuum bagged and then heated. The pressure required to consolidate the stack layers of pre-peg is achieved by vacuum. If you see, this is the blade which is mold where the blade is manufactured. You see huge size of the blade. So this is a resin infusion technology. Nowadays, most of the industries are using resin infusion technology because it takes less time to manufacture a blade. Even in one day, one blade can be manufactured. So fibers are placed in a closed sealed mode and resin is injected into the mold cavity under pressure. After the resin fills all the volume between the fibers, the component is cured with the heat. See, first on the mold you have to apply release agent and then put the fiber, and the resin is transferred through vacuum to the entire surface of the fiber. And after the entire fiber is wet, then the vacuum bagging is done and the mold is heated so that you can realize the blade. So types of resin infusion technologies, there are various types of resin transfer molding techniques. So suppose you can use the pressure also to transfer the resin into the fabric, that is called resin injection under pressure higher than atmospheric. There is another technique called vacuum assisted resin transfer molding, resin injection under vacuum or pressure lower than the atmospheric. VRTM is the most common technique used because layers of fabrics of dry fiber with nearly all unidirectional fibers aligned in the direction along with the length of the blade. So vacuum assisted resin transfer molding is the proven technique for realization of these plates because the technology is proven that various materials have been developed in order to impregnate the fabric uniformly, and it is continuously used because it's a very fast technique and we can realize any very big blade also, one blade per day we can realize. So this is another important technique which is used in the initial days of development. So this is called wet lab technique. So where dry fiber materials like mat, fabric, or unidirectional tapes are laid in various layers into the mold of the component, the layers are then impregnated with resin and cured at room temperature. Or if you use high temperature resin systems, you have to heat either in oven or by using heater arrangement in the tool itself, we can realize the blade. So this is another technique which is filament winding technique. Generally, it is used for making symmetrical cross sections, but with some addition in the tooling, we can make even the blades also, as shown in the diagram. You can see. So one cylinder, and then onto the cylinder, we can have a tooling like this, and we can use this aerofoil section blades also by using a filament winding techniques. This is capital intensive machinery. Once machinery is established and the techniques are established, we can produce blades at a very faster rate, and very accurately all the fibers can be aligned, and so that the thicknesses can be reduced. We can make efficient blades. So this is another important technique called blade infusion techniques, where most of the industries are using. Here you can see very huge tooling for the realization of the windmill blades. So two aerofoils and the webs are usually manufactured separately and subsequently bonded to complete the blade. In some technology, however, the full blade is infused as a single step also. Now, in order to meet the industry demand, so manufacturing of the blade is per day we have to manufacture maybe 2 blades, 3 blades. So once you design the tool accordingly, even spars and top skin, bottom skin can be infused in a single stage also, but the tooling will be very complicated, and we have to take a lot of care so that resin flows throughout the blade and there is no defect during the realization. So generally in the composites, there are various type of defects which will come. So we have to avoid defects in order to make the blade without any defects. So voids and dry zones, delamination, bonding defects, foreign inclusions, fiber waviness, wrinkles. These are the common defects which come in the manufacturing of the blade. So then basically there are various fibers used in the realization of these blades are called glass fiber, carbon fiber, aramid fiber, basalt fiber, then hybrid composites. Some places we can use combination of these fibers, then natural fibers. Then another important element is called matrix, that is the resin system. We can use polyester resin, vinyl ester resin, epoxy resin. Then what are the fabrics we are using, that should be sized in order to have the compatibility between the resin system. Like epoxy resins, we give silane coating. For carbon fabric, other types of coatings are given in order to have the good bond between the resin and the fiber. So glass fiber, basically we are using mostly glass fibers because it is readily available and having good strength, are used as the main reinforced materials in the composites, and with increasing the volume content in fiber, stiffness, tensile strength, and compressive strength increases. Then S-class fiber, this is also having good strength, so this is also used in some of the applications. 40% higher tensile and flexural strength, 10 to 20% higher compressive strength and flexural modulus. S-class is much more expensive than E-class. So then carbon fiber, this is very costly, generally not used, but in some specific applications where you want a lightweight, then you can use carbon fiber. Then high stiffness and low density, thinner and stiffer and lighter blades can be made by using carbon fiber. Low damage tolerance, compressive strength and ultimate strain, sensitive to fiber misalignment and waviness. So carbon fibers we have to use very carefully because it is very costly, and we have to place the fiber accurately into the mold. So if you see the stress strain graph of different fibers, you can see high strength carbon fiber having high tensile stress, then Kevlar, then S-class and E-class. Resin will have a high strain rate. So when the combination, when you make, depending upon the volume fraction, we can realize the composite blade. So if you see the cost wise also, carbon is very costly comparatively to glass. If you see glass very low, then S-class, then aramid, then intermediate modulus and high strength carbon fabric. So when you see the strength levels also, carbon fiber is having very high specific stiffness compared to the other materials. So you can see as high as 5,300 we can go. So, but E-glass will have mostly half of the strength. So density is also, carbon is having less density compared to glass. Aramid is still lighter, but aramid is having some issues like moisture and other problems, and availability is also a question mark. Then tensile and compressive properties of unidirectional composites, as shown figure, like tensile stress and compressive stress when compared to the other materials, composite materials. So main failure modes in composite materials, so composite laminates, fiber failure, then matrix failure, then fiber matrix debonding, then interlaminar failure called delamination, and buckling instability, then composite sandwich core failure, then core to face sheet debonding. These are the common failure modes of, occurs in the composite materials. So fiber failure, so if you can see the in tension how the fiber breaks. So if the fiber is continuously, if the fiber breaks in between, it will not take the desired load. Fiber have a brittle fracture, and failure occurs by unstable growth of cluster of adjacent broken fibers. So compressive load fiber can also fail in compression. So fiber failure initiates by instability, buckling followed by kinking. So if the fiber is not straight, then if it is having different shapes, then it will be failing in compression. So we need to ensure that the fiber is placed appropriately. Then matrix failure. So matrix failure is controlled by tensile or compressive stresses perpendicular to the fiber and by the shear stresses. And tensile loading involves failure of matrix perpendicular to the tensile load direction. So then compressive loading involves failure of matrix along the inclined plane. So these are the diagrams shown. If it is breaks like this in tensile mode and compressive mode. Then what are the different types of tests we have to carry out after realization of windmill blade? So we have carried out structural test of long blade, 20-meter blade, by using some structural test fixtures in our laboratory also, and we have qualified the blade. So the deflections were as high as 100 mm from the tip of the blade to the main connecting member. So wind turbine blade testing solutions are engineered to address the complete range of full-scale structural, static and fatigue test requirements used for both static and fatigue load blade evaluations. Scalable solutions designed to expand with our ever-evolving needs. Then test blades are up to 100 meters length. Now blades are, we have developed at that point of time 20-meter length, but now the blades are made as high as 100 meters length also. In complete facilities for planning ensure successful and sustainable laboratories. Advanced systems integration helps you to get the right product in the first time. So these are the different testing conditions or loading conditions. We have to apply side loads, bending moment, then tensile, compressive. So we will have different types of fixtures and apply the load as per the designer's requirement, and see that the blade withstands all the conditions of the working environment loads. So this is another type of different types of actuators we can use, and we can do the testing by using a winch assembly or by using a linear actuator assembly. We can apply the loads. So these are the different fatigue test conditions. Also we have to do the load tests. So in order to see the life of the blade, how many hours it can use, so we have to conduct the fatigue load conditions also. So there are various types of test laboratories which can conduct these type of tests, and we can qualify the blade. So you can see this is one of the different test photograph which is shown here. So these are the data which I have collected from internet only. We have also done some tests, but I don't have the figures, but we have also completely qualified the blade in order to qualify the blade for the different loading conditions like tensile load, fatigue load, compressive load, bending moment, and other functional loads. So wind energy is basically used heavily in India also, in southern India. Tamil Nadu, where the wind is continuously available throughout the year. So you can see renewable and sustainable energy source. Wind power has a green energy and potential to produce enormous amount of energy, rapid growth over the past decades, then low amounts of waste related to wind power. Crop farmers could switch to wind energy production. Windmills could be placed among the farmland also. Then wind energy is one of the most promising green technologies, then cost efficient compared to other green energies, source of tax income for local municipalities. Wind energy conserves water also, then use it for low levels of green gas emissions, then no long transportation distances for fossil fuels necessary, because it uses the wind which is available nearby. So no mining of resources is needed to produce wind energy. Then local job creation, important component in the energy transition process. The main disadvantages is it is weather dependent. Sometimes wind doesn't blow, then the energy production will be stopped. Then high initial investment cost also, the blade manufacturing, transportation of the blade, erection of the blade, and heavy engineering equipment is required in order to make the turbines for the wind energy generation. Then noise pollution is another important disadvantage of the windmill blades. So hydropower energy, this is another source of renewable energy, so which is harnessed over the decades. So we store the water by constructing the dam, and the dam gates are, water is gone to turbines by using penstocks. So hydropower is used basically in wherever the water source is plenty. So here you can see hydropower is the type of renewable energy used for generating power from water, in which kinetic energy of water is connected to mechanical energy, and with generators it is converted into electrical energy. So you can see this is the reservoir where water is transferred to the turbine through penstocks, and the turbine rotates and the power is generated. This is a very old form of renewable energy, and in India we are using extensively wherever plenty of water is available and stored by using the construction of the dams. So this is the diagram. You can see how the water is flowing and the turbine is rotating and power is getting generated. Hydropower system converts kinetic energy of flowing water onto electrical energy. Flowing of water turns the propeller called a turbine. The turbine turns metal shaft of in an electrical generator, which produces electrical energy. So hydropower known to everybody, so I am not going into deep details. So these are the pros and cons of the hydropower. Renewable source of energy pairs well with other renewables, can meet peak electricity demand. Then some adverse environmental impacts, then expensive upfront, because the construction of dam is very expensive and it takes decades to build a dam. Then lack of available reservoirs. Then another important form of energy nowadays people are harnessing is called tidal energy, where you can use tides in the ocean to generate the electricity. This is one form of new technology development. Tidal energy is using because of the advancements in technology. We can harness this ocean tides into making energy. So it is a form of hydropower that can convert energy from tides into useful form of power. They are relatively high cost and limited sites with high tidal ranges or flow velocities. Tides are more predictable than wind and sun. Some of the main tidal energy plants are situated in South Korea, then France and United Kingdom. So here you can see schematically when the tides are coming, the blade will rotate and it will generate the electricity. So this research is going on till to improve how to harness this energy. So the tides which are generally in the ocean, tides are coming regularly, so we can harness this energy but initial investment and other things are very important. So this is tidal power or tidal energy is harnessed by converting energy from tides into useful form of power, mainly electricity, using various methods. Then tidal energy was invented by engineer named Dexter Cooper in 1920. We can use tidal energy to supply electricity to our houses and business purposes. So tidal barrages we can use in order to harness the tidal energy. Tidal barrages make use of the potential energy in the difference in height or hydraulic head between the high and low tides. When using tidal barrages to generate power, the potential energy from the tide is seized through the strategic placement of the specialized dams. So these are the different types of turbines we can use to use the tides and generate the electricity. So these are the potential areas where tidal energy can be harnessed. It is shown in the internet. So the same thing is produced here. Then various advantages and disadvantages of tidal energy: consistent power, pollution free, low operation cost, efficient, tides are predictable, then renewable, impacts are local or not local, provides storm surge barrier. The disadvantages is marine life is affected and high initial cost. Then technology is still maturing to use this tidal energy completely. Then biomass energy, this is the different one of the renewable resource energy which is can be used or harnessed for generating the renewable energy. So biomass is an organic material that comes from the plants and animals. Biomass contains stored energy from the sun. Plants absorb the sun energy in the process called photosynthesis. When biomass is burned, the chemical energy in biomass is released as a heat. So in most of the villages, this biomass energy plants are made in order to harness the biomass which is plenty available in villages through animal waste and other resources from the environment and from the forest. So here we can use whatever the available resources, and from that the gas is generated and the gas is converted into electricity. So these are layout of the biogas where we can use forest residues, then recycled wood, impregnated wood, and it can be converted into biogas. And with the biogas we can use for various purposes, for buildings, then industries, direct lighting, and then for cooking purposes also we can use. So these are some of the advantages and disadvantages of biofuels. Green energy, then biofuels are renewable and sustainable energy source. Energy unit price of biofuels is quite low. So these are some of the advantages listed here and disadvantages. The another form of important renewable energy source is geothermal energy. So here we can use gases which is produced in the earth by tapping the geothermal energy. So we can generate the electricity by using turbines and cooling towers. So this is we have to find out where the geothermal energy is available. From there only we can generate the this energy for different purposes. Geothermal energy is a type of renewable energy taken from the Earth's core. It comes from heat generated during the original formation of the planet and the radioactive decay of materials. So this is first invented by 1904 by Prince Pio Ginori Conti invented the first geothermal power plant at the Larderello dry steam field in Italy. So resources of geothermal energy range from the shallow ground to the hot water and hot rock. So in United States, the largest producer of geothermal energy, that is around 17,415 megawatts. So these are the advantages of geothermal energy and disadvantages of geothermal energy. So here we have to find out where the resource is available, and we have to tap the resource, and we can generate the power by using the geothermal energy. So in India, what are the renewable energy we are using? That is given here. So renewable energy in India, India is the world's third largest consumer of electricity and world's third largest renewable energy producer, which is 38%, 136 gigawatts out of 373 gigawatts of the total installed energy capacity for the year 2020. As of September 2020, 89.22 gigawatts solar energy is already operational. Then projects of 48.21 gigawatts are at various stages of implementation, and projects of 25.64 gigawatts capacity is under various stages of bidding. So most of the states are now depending upon the investments. So they are going into solar energy and renewable energies of different sources, as I explained, like windmill energy, then biomass energy, then geothermal energy. So our in defense also we are using most of the solar energy wherever it is possible. So we have installed many places solar power plants wherever land is available. We have installed solar power plants and using heavily. Then wind energy in India has a strong manufacturing base with 20 manufacturers out of 53 different wind turbine models of international quality, up to 3 megawatts in size, with exports to Europe, United States, and the other countries. So windmill energy requires a strong windmill blades. Those manufacturing plants are available plenty in India. So we have initially developed the technology for manufacturing by using hand lathe technique. Now a lot of industries like Sujalon, then LMW, these are the industries which are manufacturing blades of very high length, as high as around 50 meters to 100 meters also they are developing. And Netherlands is the main country which is producing most of the windmill blades, which is supplied to globally to all other countries also. And India also is gearing up in meeting the world's requirement of these windmill energy blades. And windmill energy is nowadays people are thinking to even on the ocean surface also a lot of wind is blowing. So how to tap this energy by installing these windmill blades in the ocean? That also a lot of research is going on, so that we can tap most of the renewable energy source from the windmill blades. So India is the fifth globally installed hydroelectric power capacity as on 31st March 2020. India's installed utility scale hydroelectricity capacity as high as 45,699 megawatts, or 12.35% of its total utility power generation capacity. India is an ideal environment for biomass production, given its tropical location, sunshine and rains. The country's vast agricultural potential provides agro residues which can be used to meet energy needs both in heat and power applications. So biofuels India is using, but still we can increase the percentage by properly educating the people in the villages how to produce electricity from this bio waste. In 2018, India set target to produce 15 million tons of biogas by installing 5,000 large-scale commercial type biogas and bio-CNG plants, which can produce around 12.5 tons of biogas or bio-CNG by each plant. The number of small family type biogas plants reached around 3.98 million. So renewable energy in India, if you see, Tamil Nadu is having advantages of wind continuously throughout the year. That's why most of the windmill blades are installed in Tamil Nadu, Maharashtra, and some parts of Andhra Pradesh. The development of wind power in India began in 1990s and has significantly increased over the last few years. As of 30 June 2018, the installed capacity of wind power in India is around 34,293 megawatts, are 10% of India's total installed power capacity, mainly spread across Tamil Nadu, Maharashtra, Gujarat, Rajasthan, Karnataka, then Andhra Pradesh and Madhya Pradesh. So in my native place in Anantapur also, there are a lot of windmill blades which is put in Tadipatri, near Tadipatri. So there is a continuously wind blowing in that area. So Sujalan also has put up windmill blade near that area. So renewable energy in India, if you see, India has set up an ambitious target to generate 60,000 megawatts of electricity from the wind power by 2022. So in India, government's Ministry of Renewable Energy announced a new wind solar hybrid policy in May 2018. This means that the same land will be used to house both the wind farms and solar panels. So if you can see the Sujalan energy, which is generating most of the windmill capacity 1.6 gigawatts. Then in Tamil Nadu, wind farm, then wind farm in Maharashtra, then wind farm in Maharashtra again, then Sujalan energy. So this is the capacity which is generated by windmill blades, wind farms in India. So now compared to solar energy is also largely floating solar power plant in India. Recently it came in newspapers also. In Visakhapatnam, we have government of India has established a large solar power floating project. So NTPC started operations in India, largest floating solar PV project at Visakhapatnam, known as Simhadri floating solar PV project with a capacity of 15 megawatts. Solar power plants in Telangana also, lot of government is giving lot of thrust in order to generate solar power plants, because most of the time we have sun available throughout the year. So a lot of schemes are announced by government in order to increase the solar power. But most of the apartments and villas also now generating its own solar energy. So that is a good sign that we are harnessing solar power even for domestic applications also. So one of my friend recently I visited him. He has installed solar panels in his apartment, in his villa. The entire power is coming from solar power only. So these are the in India there are many places solar parks are approved. So in different states and different places, and government is giving subsidy in order to encourage the harness of solar renewable energy. Then these are the capacities already installed in various states like Rajasthan, then Gujarat, Maharashtra, Karnataka, Andhra Pradesh. These are the installed capacities which is shown here. Then there are cities identified as solar cities in India, and the government is giving a lot of encouragement in order to generate solar power. Recently, I visited Cochin for some official work. There, I came to know that the entire airport power is harnessed from solar. So the complete renewable energy is used for the entire airport operations and airport maintenance and the lighting in the airport, even air conditioners, and everything is run by solar power. So that is one good sign that we are using solar power efficiently in many of the places. So these are the companies which are working for renewable energy sources in various domains like solar, then windmill, then other applications also. So if you see the energy mills, windmill energy, how much time it will take? It takes almost 2 years to establish a blade manufacturing company in order to produce the blades. So year-wise renewable energy generation as per the data available in the internet. So we can see large hydropower plants, this continuously it is increasing. Then small hydropower plant, then solar if we can observe from 2014-15 to 2021, So it is increasing to almost 50 gigawatts. Then biomass also increasing, then other renewable energy sources. We can see the total renewable power from 17% we have coming up to 21.25%. Still, it has to go a long way in order to completely harness the renewable energy. So these are the other tabulations which is available in the open domain. So you can see non-renewable energy sources like from thermal power plants, nuclear power plants, diesel power plants. We are generating around 64%. And renewable sources like tidal power, solar power, wind power, biomass, from other renewable energy sources, it is coming to 35%. So if you can increase this to 50%, then our normal biofuels or diesel or nuclear power we can reduce, and the pollution also we can reduce, so that non-renewable energy sources we can harness completely, so that it is available in plenty and there is no dearth for the renewable energy sources. If you go after 20 to 30 years, we may end up with coal or you may end up with diesel. But renewable energies are available plenty. We have to harness renewable energies in order to meet the future requirements. So off-grid renewable energies installed SPV systems, then biomass gasifiers, waste to energy. So the total capacity of 1.2 gigawatts. Then if we suppose encourage in renewable energy systems at household levels also, we can increase the consumption or production of the renewable energy. So if you see the market size, renewable energies 2194.5% and 2297%. So installed energy capacity is growing steadily. Then this is the various powers available as per the literature: solar power, then wind power, then biopower, and small hydropower. So you can see wind power is contributing to 40%. Then solar power is contributing to 43%. And biopower is less, and small hydropower plants also less. So when you see the how the electricity generation from renewable energy sources is taking market share. So if you see for the year 16, 65.8 billions, then for the year 17, 81.5, 18, 101.8, and the year 19, 126.8, then 20, 127. So government is giving a lot of thrust in order to use the renewable energy sources like green energy corridor, wind solar hybrid policy, and solar parks and ultimate solar power projects. Government is giving a lot of thrust in order to reduce the solar panel cost and production of solar equipment. So this is a good initiative. So then advantages of these policies are we are increasingly going to increase the renewable energy usage. So Prime Minister also giving a lot of thrust in order to use the renewable energy sources in solar, wind, etc. So these are some of the policies which are introduced by Indian government. Indian Renewable Energy Development Agency, IREDA, has invited bids for solar module manufacturers, setting up in 4,000 worth of around 4,500 crores in order to increase the energy source. Thank you very much for giving me an opportunity to share some of the work which we have done in renewable energy sources. So participants, any discussion, we can continue the discussions. I will stop sharing.
Participants, please make any queries. From participants, please, or you message in chat box also. Sharath Reddy, someone has raised hand, please.
Good morning, sir.
Good morning.
Sir, I just wanted to ask that actually my work is on hybrid energy system. So I have some queries about the what are the challenges which we have to face while installing the biomass plant in rural areas.
Biomass plants in rural areas.
Yes, sir.
So, what
Because
we have
I
to
am incorporating that with my system, and it is becoming a little bit costly. So how we can reduce this cost of this plant?
okay. So generally, these biomass plants, we have to educate the people what is the usage of the biogas, and we have to collect the whatever the waste resources available uh, uh, in whatever the manner the resources are available. We have to collect and then use those raw materials to generate the biomass. So actually, I am not into that research biomass. I am an expert in making composite windmill blades. That's the reason this topic has been selected to give the lecture. So, Rameshwari, anybody can give answer for madam's question?
Okay, sir. Please, anybody in the participants, any idea?
There is a question in the chat box. Sir, there is a question in the chat box. What is the procedure to mark the attendance? Oh, sorry. Sure, sir.
Okay, thank you, sir. No issues.
Thank you, madam. Thank you.
One more question was there. What is the size of solar panel required to install for 1 kV, 1 kilowatt?
1 kilowatt.
What is the size of solar panel required? It is posted by Mr. Madhusudan.
Yeah, actually it depends upon the intensity of the light available in that area, and also the available area also. Maybe around 10 meter by 10 meter will be sufficient for generate 1 kilowatt energy, as per my knowledge. If somebody is working directly on solar energy, they can give the correct answer.
Okay, thank you, sir.
One more question. Please give information about half cut and diamond cut solar panel.
Half cut and diamond cut.
Solar panel.
Rameshwari, really I don't have answer. If anybody is having answer, they can give.
Yeah. Okay, sir. Okay. Okay, fine, sir. Someone has raised hand. Dr. Nisa Singh, what is it? Hello. Someone has raised a hand. Dr. Nisa Singh. Sharath Reddy. Sharath. Okay, sir. Huh? Rachana. Okay. No problem. Okay, sir. Can you share it the PPT, sir?
Yeah. I will share it to you.
Yeah, fine, sir.
Okay.
Okay, sir. Okay, dear participants, it is nice session given by Dr. Kishore Nath, sir. Okay, sir. Thank you, sir, for your valuable suggestions given by regarding renewable energy overall. Okay, sir. Thank you, sir.
Thank you, Rameshwar Reddy.
Okay, sir. Thank you.
Okay.
Yeah. Regarding attendance, it will be posted soon with the Google form. Next session will start by 11:15. Sharath Reddy, please.
Hello.
Hello, sir. Tell me, sir.
Sir, this session attendance link is given or not?
No, sir. It is not required for daily. Only one
Hello.
attendance will take. Not required every session, sir. At any time, we will give the link, sir, in 3 sessions, sir. Only one Google form will send for one day. Session wise is not required.
Okay. Okay.
Also, we are monitoring on the Google platform, sir. Attendance monitoring is there. Separately, I think we don't want required. Anything we required, I will send, sir.
Is the Google Form sent to the WhatsApp group which you have created regarding this FDP?
Yeah, I will send, sir.
Okay. It is a very it is very helpful if you are sending the Google Form to the WhatsApp group, because sometimes it's a network issue which will be provided on this behalf of this region. So that is if I could submit the Google Form, that is that is going wrong, right? So basically, if you are sending the Google Form to the WhatsApp group, which will be very helpful, not for me but all of them actually.
Yes. Thank you.
No issue, sir. We will definitely forward.
Yeah. WhatsApp group में भेज दीजिए. Thank you.
Yeah. Okay, sir. 11:15 again. The session will going to start. Please make to leave this, sir. Please.
Yes, sir. Okay.
Okay, sir.